Hello, this lecture is about risks, threats, vulnerabilities, and impacts. So mainly want to talk about first the definitions about threats, vulnerabilities, and risk. How do they behave? Then next I want to discuss the risk assessment method tool, which is FMEA. First, the terms threats, vulnerability, risk. These are the three different concepts. Threat means usually that's an action or potential action that's likely to cause damage or harm or loss. While vulnerability is mainly these are the weaknesses or the features or the gaps that are prone to some of the consequences or threats. And the risk of these are the impact or the effect of uncertainty of objectives. So mainly, what is what is the potential impact from those weaknesses? And this is an example. We can take a look at it. And in a system that allows a weak passwords. In this case, the vulnerability will be the password is vulnerable, for dictionary or exhaustive key attacks. Well, how do we describe threat? Threat will be because of the action. So we can say that an intruder can exploit the password weakness to break into the system. While the risk will be the resources within the system are prone to illegal access or damaged by the intruder. So which means that the impact will be the resource will be resource from the system will be damaged or modified. So these are the three different terms about threat, vulnerability, and the risk. And another term is resilience. So resilience, when it happens when vulnerabilities are balanced by capabilities. So you can tell that when the capabilities are going up, actually the resilience is also go up, with low vulnerabilities. Another thing is want to understand is the resilience versus the efficiency. So resilience versus the efficiency. So sometimes resilience is actually it's different. It's contradict to efficiency because the more efficient actually the system may not be that resilient. So this is an example. For example, if I want to transfer transfer material from A to B directions. All right, so there is one road to go from here. Well, we know that the segment or the line or straight line is the shortest distance from A to B, which is the most efficient way to transfer material from A to B. However, if there is some accident happening in the middle of A and B, for example, the bridge is collapsed or the road is blocked, then what happens is then there's no way to transfer A from A to B. Well, so which means that there's a big impact, right? If there are multiple ways, say from A to B, we have this path, or even this path, right, to move material from A to B. Yes, if we go from this path, it's not as efficient as go straightly from A to B. Or if we go to this length, this path is even longer, and the time is taking is much longer. So which means that these two ways are not efficient, but by having these two ways, it will actually add resilience to the system, because when the road of this straight line is blocked or damaged, there are actually multiple ways to achieve the same goal. So this is how the resilience versus efficiency. So sometimes, for example, when in the manufacturing system, if you want to have the system more resilient, we probably want to develop some of the multiple ways for this function. Like an important, let's say, hospitals, the power hospitals. The power hospital actually they have at least two power sources. The one is from our public electricity source. While another one is the internal power generation. So when for example when there's a power outage from the public, but the hospital still have its internal power to support the patients and also the running of the hospital, because these are very key or critical infrastructures to the society. You can do a little bit of exercise with think about how to identify the threat, vulnerability, and also the risk of these systems. For example, in the classroom, right, in the class. So what are the threats might affect the running of the class? And maybe a person just break in and then disturb the lecture, or maybe something else might happen to the lecture, right? And also the vulnerabilities. Think of this whole classroom setting. Many things can go wrong, right? So, for example, the technology, right? Maybe the projector is not working. Then, if I do not have any backup materials like writing on the board, then that probably gonna greatly affect the efficiency or the delivery of the lecture, and so the risks will be the impact. Same. Think about the technology will go wrong. What kind of impact will it be, right? So the impact can be, okay, that maybe we just stop the class, or we cannot finish this lecture, or we might have to schedule another time to gather all of you go together for another class. So these are the some examples that you can come up with to identify the threat, vulnerability, and also the risk of those systems. Same with the CNC. There are multiple ways that for threats, for vulnerabilities, and those risks. So how do we calculate the risk? Because the risk is actually equals to threat, vulnerability, and also the consequence. And so we can use threat times vulnerability times the consequence. Consequence of the impact. Vulnerability is mainly related to the features or the capability of the system, while the threat itself is mainly related to the choice of the model of the system. In terms of the cyber physical systems, there are several many actually threat actors. We can categorize those into three groups. The one is the mainstream. So mainstream will be the largest group. They are typically unorganized, and they either want to have some of the fame or have some other purposes. So these are a little bit actually it's hard to identify. And also hard to manage, because they do not have a clear goal or purpose. All they want to do is just to make some of the damage. And another type of the group of the threat is organized. So organized means these are some typically criminals or activities that have some intention to revenge. And blackmail or attracting attention. Well, another type of or group of the threat will be the terrorist or nation or statewide, funded and well organized. So their purpose is intended to spread fear or distrust society or supply chains. So this is the threat matrix. You can tell that they categorize the threat into the insider factors and also the outsider factors, and it can be targeted impact or intended impacts. from different threats. So you can use this matrix to help you identify, what kind of threats, around the system, either inside or outside, or targeted or unintended. And different type of the attacks, especially related to Internet of Things. And so these are typical ones. Of course, there are many different kind of attacks. These are typical ones: 0-day, man in the middle, and also the denial of service, and also DDoS. So let's first look at a 0-day.
Zero-day exploits are when a malware exploits the vulnerability. What is zero-day exploits? Software is released for the users after several testing phases. However, it is never perfect. There are always unforeseen flaws. To resolve these issues, the developer subsequently releases updates. The problem could be reported by the user or discovered by self-testing. However, when this vulnerability is discovered by criminally inclined people, it can be exploited for nefarious purposes. They can use it to gain illegal access to users' computers by injecting a malware. This type of vulnerability is called zero-day vulnerability. When an attacker exploits it, it's called zero-day exploits. Attackers exploit these vulnerabilities by various means. Web browsers and software like Java and Flash are more vulnerable, so attackers might locate unsecured users through email attachments or software bundles. Zero-day attacks occur within a specific time frame, known as a vulnerability window. This is the time beginning from the first vulnerability exploit to the point at which a threat is countered. Zero-day attacks are strategically implemented to cause maximum damage within a short span of time. How to stay away from zero-day exploits? As you know, there are no immediate fixes available to resolve the exploit because the developer is still unaware of its existence. For a better protection, you should have a behavioral blocker installed on your system. It monitors the behavior of all programs. When a program takes action that matches the malware description, it blocks that program. Thus, the zero-day attack is prevented. MalwareFox Anti-Malware has a behavioral blocker integrated into its system and is a proven anti-malware product that safeguards.
Next is man in the middle.
Hi, in this video you will learn about what a man-in-the-middle attack is, or for short, MITM. A man-in-the-middle attack is usually observed in a client-server environment. A client is a computer hardware or software that accesses a service made available by a server in the network. A server is another computer system whose services are accessed by the client through a gateway. A man-in-the-middle attack is when a hacker gets in between two endpoints, a client and a server. A simpler way to understand a man-in-the-middle attack is a game. I like to call it the cup telephone game. Do you remember the game where you talk to your best friend through a cup and a string? So let's just say Ryan and Callie were having a conversation through the cups. A kid named Jake wanted to listen in. So he cuts the rope and puts cups to his ears. Jake would then tell Callie that he is Ryan, and then tell Ryan that he is Callie, so he would be able to intercept the conversation. In this video, you learned about what a man-in-the-middle attack.
Denial of service.
Hello everyone. This video is about the differences between DOS attack and DDoS attack and how to prevent the DDoS attack. So, what is DOS attack? A DOS attack stands for a denial of service attack, which means a single attacker attacking a single target. This means that one computer and one internet connection is used to flood the server with packets. The attacker sends a large number of legitimate-looking requests to the server in a way that the server cannot really distinguish between valid and non-valid requests. It will overwhelm the system to a point that the server cannot handle the capacity anymore. The point of such denial-of-service attack is to overload the targeted server's bandwidth and other computing resources. This will make the server inaccessible to others. And what is DDoS attack? DDoS, the DDoS attack, stands for a distributed denial-of-service attack. In most respects, it is similar to DOS attack, but the results are much different. Instead of one computer and one internet connection in normal DOS attack, the DDoS attack utilizes many computers and many connections. The computers behind such an attack are often distributed around the whole world and will be part of what is known as a botnet. So the first step of launching a DDoS attack is to recruit an army of bots. In order to turn a computer into a bot, the attacker develops specialized malware, which spreads to as many vulnerable computers as possible. Malware can spread via compromised websites, email attachment, or through an organization's network. Users who was tricked to running such malware will unintentionally turn their computer into a bot and provide access points to the attackers to their computers. Once a computer turns into a bot, it connects to the attacker's command and control server and begins to accept orders from the centralized machines. The orders from the command and control server include the direction for launching an attack from the bot's malware to a particular target and the selected attacking method. An army of bots is named as botnet and usually consists of thousands of bots. Anytime the botnet owners want to launch an attack, they send messages to their command and control server with the instruction to perform the attack on a particular target. Any infected machine in the botnet will comply by launching a coordinated, real-time distributed attack known as a DDoS attack. The main difference between DOS and DDoS attack is that there's only one attacker in DOS attack, but in DDoS attack, the target server will be overloaded by hundreds or even thousands of requests. Therefore, it is much harder for a server to withstand a DDoS attack as opposed to the simpler DOS incursion. So, how do we prevent a DDoS attack? DDoS attack comes in many different forms. One of them is called Trojan. The attacker usually sends a link with Trojan, and if the victim opens the link, the attacker can do whatever he wants with the computer. So the simplest way to avoid DDoS attack is making sure not open any link that you're not known of. You can also get a professional company to help you mitigate the attacks. The company will install NetFlow protocol, which monitors traffic to your site. If you are serving your own data, making sure all your routers drop junk packets, block ICMP when you don't need it, and set up a strong firewall. So, how do the companies prevent the DDoS attack? Large companies lease a significantly larger capacity than they need to for a DDoS attack. If the attacker is unable to take over enough traffic off the site, the attack is generally ineffective. Some companies have tools which monitor NetFlow data from routers to determine a baseline for traffic. If they detect any traffic that steps out of the zone, the DDoS mitigation tools can attract the traffic and filter it out. Many large companies often implement either a DNS-based redirect service or a BGP-based service to protect them from attack. Those services can help the company stay online during an attack. So this is the end of our video. Thanks for watching and goodbye.
All right, though that was a different type of attacks, and so today we're going to introduce a risk assessment method, which has been widely used in not only in manufacturing but also in aerospace and also many other systems, including products. It's the method is called FMEA. The full name is failure mode effect analysis. First, what is a failure mode? A failure mode basically is the way in which the component or subassembly, the product or input or process could fail, right, to perform its function. And so basically, it's what things can go wrong. Why are we using this method? So we're using this method is mainly to facilitate the process improvement or trying to identify what are the potential ways to go wrong, in the early product design stage. And it focuses on the prevention. So trying to identify those risks before adverse impact happens. So sometimes FMEA can be a customer requirement. So customer, when you deliver a system to the to a customer might require FMEA in order to identify what things can go wrong, what the impact it can be, and also what ways to mitigate or solve the problem. And also maybe it can be required by an applicable quality management system, for example ISO. And so FMEA estimates the risk associated with the causes, and also prioritizing the actions that should be taken to reduce risk, because there are multiple ways that the system can go wrong. So you have to give a priority on how to solve the problems and what are the main focuses to the risks. And so when do we conduct FMEA? It can be at different stages. We can do it in the early design stage of the products, the system, or the processes, or we can do it in the process improvement stage. The process improvement stage will be identify what process what aspect of the process can go wrong, and also based on the impacts or something that already happened to the process, that we can come up with solutions in order to improve the system performance. And a lot of time we are using we can carry out the designs when they are used in the new applications, because when we have certain designs and then they have been used in the prior systems, has been very well, but when it comes to a new application, there are a lot of uncertainties, so we have to find out or trying to identify the risks that what things might go wrong. And a little bit of history is first being introduced in 1960s, in the aerospace industry during the Apollo missions, because in aerospace, there are so many components in the system, and this is also the place where systems engineering actually got involved, because in the early stages, NASA and aerospace industry, they trying to design this big system, but many things went wrong. Only a very small component went wrong that actually caused a big impact. So that's why they had to trying to develop the whole theory or principles, trying to find out how can they mitigate this kind of risk. So that's why system engineering got developed. And so FMEA is one of the tools that also got developed by aerospace industry, trying to identify those risks. And later they have been used in the Navy, and also later in industry, and now in a lot of softwares, products, automotive industries as well. And this is a typical FMEA form. So it has composed of several components. of course, these are the headers, give a little bit background information about what is the process or product or the system we are trying to analyze, and these are the processes or the features that you want to identify. What things might go wrong with the process. So these are the processes, and these are the failure modes. So in what way things can go wrong, and these are the potential failure impacts or the effects. So there are three numbers you might want to pay attention to. The one is severity, the other one is occurrence, and also the detection. So severity means the significance of the impact. After we identify the potential failure impact effects, we can give a score to try and look at how severe it is, and also we need to identify what is the potential causes, right? What causes this impact, and also the occurrence means how often it can happen in a system, right? So what is the probability? What is the chance of it happen for this to go wrong? And lastly is detection. So detection means, all right, so we have this this feature can go wrong, or this mode can go wrong, and these are the potential causes, but there's supposed to be some of the controls that actually affect or controls this mode. Then how easily can we detect, or how difficult can we detect this failure mode. So this is detection. If it is really difficult, you might give a score. If it is really easy to detect, you might give another score. Then the three numbers, severity, occurrence, and also detection, will determine this risk priority number. Risk priority number. So risk priority number equals to severity times occurrence times the detection, right? So after you calculate this risk priority number, you can come out with the actions, right? You need to figure out what this happens. So what can we do in order to solve this problem, right? So this is the actions recommended. So how do you solve this? Who will be responsible to solve this, and also if actions have been taken based on those actions, right? And then after you calculate that, after you do the actions, then you can calculate again what is severity, occurrence, and detection after you implement the actions. So this is another component of the FMEA form. So basically, this is a general setup of the FMEA. So mainly, you just need to identify what process you are looking at, what failure mode it is, what is potential impact, give a rating of the severity, identify the cause of the impact, give occurrence number, occurrence rating, and also what is current controls and how difficult it is. And then give a solution, and then calculate the new scores again. And so type of FMEA is mainly either related to design or process. For the design, mainly we conduct the FMEA before the product the product design release to the production. So mainly we want to focus on the product function. It also analyzes the systems, subsystems in early concept or design stages. While if we are looking at the processes, mainly we are looking at either a manufacturing or assembly process, after they are implemented. So in terms of using FMEA, it's typically a team approach. So which means you group a team of people from different functions, not just yourself, you or or a group of people that's only from a single function, because you might want to bring in many different perspectives in order to complete the whole FMEA, have a better understanding of the failure mode. So a team, it can be led by the process owner, who is responsible for manufacturing engineer or technical person or similar individuals, familiar with FMEA. If it is in a production setting, you might want to consider the design engineers, process engineers, material suppliers, customers, operators, reliability suppliers, all getting involved in completing this FMEA, because they understand better about what they contributed in the in the product or in the process. Then they understand better what could go wrong in the system. So this is why it's desired that you have a team of people that from different aspects of the system. And a typical procedure is, I have already identified, in the example we just showed, that first, find out each process input and determine ways that the inputs can go wrong. Then you, for each of the failure mode, determine the impacts or the effects, right? So select the severity level for each effect, and then identify the potential causes of each failure mode, and then also come out with occurrence level, which is how likely or what is the probability it can happen. And list the current controls for each cause. Select the detection level. It is hard or simple to detect. Then calculate the RPN. Then develop recommended actions, assign responsible person, and also take actions. Then assign the predicted severity after action has been taken. Right, so give a prediction of the severity, occurrence, and also detection level, and compare the RPNs and see if the action suggested can make sense, make a difference. And so the input for the FMEA, mainly these are the processes, the procedures, the knowledge, and also your understanding about the process and the products. Then after that FMEA process, what it come out with, basically these are a list of actions to prevent causes or detect failure modes. And some of the application of the FMEA or simple version of the FMEA, actually you can see in the products menus. Something you purchase, you probably notice that there's a page and see the common issues and fixes, right? So these are one simple type of FMEA that you can include in the products. So this is the calculation about the RPN, and you can give a rating. Typically, the ratings scales are from 1 to 10. It's not only the two numbers, right? It can be 2, 3, 4, 9, or 10. Depends on how what is the level of the rating here. I'll post the folder on Canvas, so you can take a look at an example of FMEA and how they write the statement FMEA, identify the failure mode and also give actions. Then you can actually do a little bit exercise on yourself. For example, driving a car on the moon, just think about what things can go wrong, right? It's different failure mode. Maybe the car can go wrong, or maybe your suit can go wrong as well. Then based on each of the failure mode, if the car goes wrong, then what is severity, right? How likely it will happen? It is a high probability or it's low probability. Then what is what is the impact, right? If it goes wrong, what is the impact? And then you can give out solutions. So how do you make sure that the car will not go wrong on when it's running on the moon? Same is traveling in a war zone, or you can do a little bit analysis being in a relationship where where things can go wrong, and how do you come up actions to do that, and then give an evaluation of the process. All right, so these are the stuff we want to talk about risk management or system vulnerabilities, and also we introduced the method FMEA. It has been widely used in production and industry, so this is a tool that you have to understand and know how to use it. All right, that's all for today.